Hi and welcome back. Today I'm going to demonstrate how I go about forging a hammerhead. Now, even though this technique can be used to forge any size of hammerhead that you want, I do have to say that I rarely go about forging a larger hammerhead from scratch. I usually find that it's more efficient to recycle an existing hammerhead like a small sledgehammer or something into what I need than to take the time rough forging a blank, which is pretty much going to look like a sledgehammer anyway, and then transforming that shape into the hammer that I need. Small hammers, on the other hand, are fairly quick and easy to make, and there aren't as many good small hammerhead blanks that you can use to recycle into hammers, so I usually go ahead and forge those from scratch. So that's what we're working on today. I'm going to be making a small raising hammer that I'm going to be using in the next project. Now, the first thing you need to consider when you're forging a hammerhead is the drift that's going to be used to shape the actual head of the hammer. And for all my small hammers, I usually use a very simple, straightforward drift. This one has the two edges parallel with each other and the front and back face with a very slight taper. This taper goes right from the front of the hammer to the base. It's not funnel shaped like a commercial hammerhead. The reason I do this is because it makes setting the handles really quick and easy. I can take the dimensions right off the base of the hammer to shape the end of the hammer handle. I can measure the length here, the width here, and that's it. It's just a matter of driving the hammer handle into the head and then setting the wedge, and I'm done. In this heat, I'm forging down the sharp corners of the hex bar. I want a large rectangular cross section where the eye of the hammer is going to be. The finished dimension here is going to be roughly 1/2 inch by 3/4 of an inch. I'm taking my time finishing this heat because I want to make sure that all the edges and the faces are as true to each other as I can make them. This is really going to help out later on when I come to drill the holes that are going to rough out the eye. The next couple of heats are just going to be to rough out the hammerhead shape. I want to try to get as much work done as I can before I cut the head from the bar. At this stage, the head has been annealed. I've ground the edges so that it'll sit squarely in the drill press vise, and I've marked the location for the holes. As you can see, it isn't necessary to drill out all the material for the eye. It is important, however, that you size the holes to match the punch that you're going to be using to drive out the remaining material. Ideally, you want the holes to be roughly the same as the thickness of the punch. You can see how drilling out that little bit of material allows you to punch and drift the eye without distorting it. It's important to understand that this punch is going to follow the drill holes, so it's really important to take your time, make sure everything's square and those drill holes go in straight, because it's going to be very, very hard to correct anything once the holes are drilled. And here's the finished hammerhead ready for the handle. It's been ground smooth and tempered to a dark straw. Hickory doesn't grow around here, so I usually wind up buying sledgehammer handles and shaping them into the hammer handles that I need. I try to rough out as much as I can on the bandsaw, and then I head over to the bench to do the final shaping. I usually finish the hammer end of the handle first, that way I can drive it into the head and I can use the head in the vise to help shape the rest of the handle. So there you have it, the basic hammer. This one only took about 45 minutes to an hour to make. We'll see you next time.